Hello, today you will learn about object-oriented programming, OOP. It is a programming paradigm that organizes code into objects, which are instances of classes. It is based on the principles of encapsulation, inheritance, polymorphism, and abstraction. Encapsulation, at its core, encapsulation is about bundling data and methods into a single unit known as a class. Example, car class. Consider a car class. It serves as a blueprint, defining properties like make and model, and behaviors such as start engine and stop engine. Access modifiers. Encapsulation often employs access modifiers like private, protected, and public. Private members are accessible only within the class, while public members can be accessed from outside. Here in our example class, we have public, protected, and private variables. Information hiding. Encapsulation enables information hiding, concealing internal details from the outside world. This reduces complexity and prevents unintended interference. Users interact through a well-defined interface formed by public members, getter and setter methods, to access or modify private attributes. Getter and setter methods are employed. Getters provide read access. Setters allow modification with constraints if needed. Example, bank account class. In our bank account class, we use getter and setter methods for the private balance attribute. Encapsulation and security. Security is enhanced by restricting direct access, ensuring data is only accessed and modified through defined interfaces. Encapsulation and code maintenance. Encapsulation promotes code modularity, easing maintenance. Internal changes don't impact external code as long as the public interface remains unchanged. Polymorphism. Polymorphism, derived from Greek, means many forms. It allows different objects to be treated as instances of a common base class. There are two main types of polymorphism: compile time, method overloading, and runtime, method overriding. Compile time polymorphism, also known as method overloading. Method overloading occurs when multiple methods share the same name but differ in parameter lists. The compiler determines which method to call based on the provided arguments during compile time. Runtime polymorphism, also known as method overriding. Method overriding takes place when a subclass provides a specific implementation for a method in its superclass. The decision on which method to call is made at runtime, allowing for dynamic behavior. Runtime polymorphism involves multiple methods with the same name but different parameters. Interfaces and polymorphism. Interfaces provide a way to achieve polymorphism by defining a common set of methods. Objects of different classes that implement the same interface can be treated uniformly through the interface type. Advantages of polymorphism. Polymorphism brings several advantages to programming. It promotes code reusability by using a common interface for different object types and provides flexibility during code design. Inheritance. Inheritance involves a base class, providing common attributes and behaviors, serving as a blueprint. A derived class inherits from the base class, extending or specializing its functionality. Syntax for inheritance. In most OOP languages, inheritance is declared using specific keywords like extends in Java or : in Python. The derived class indicates the base class it inherits from and can add or override attributes and methods. Access to base class members. The derived class inherits public and protected members but not private ones. In some languages, the super keyword is used to refer to base class members. Method overriding. Method overriding allows the derived class to provide its implementation for a method in the base class. The overridden method in the derived class must have the same signature as the base class method. Types of inheritance. Inheritance comes in various types, including single, multiple, and multilevel inheritance. Advantages of inheritance. Inheritance brings several advantages to our code. It promotes code reusability, allows easy creation of new classes, and enhances readability and maintenance. Abstraction. abstraction often goes hand in hand with abstract data types, ADTs, providing a high-level description of data and operations without detailing the implementation. Think stacks, queues, and lists, where users interact with data through a clean interface, unaware of the underlying complexity. Abstract classes and interfaces. Abstraction in OOP is realized through abstract classes and interfaces. Abstract classes can't be instantiated and may house abstract methods, while interfaces define contracts for implementing classes. A class can implement multiple interfaces. Hiding implementation details. Abstraction is about concealing the nitty-gritty details, exposing only what's necessary through a well-defined interface. This practice manages complexity, allowing developers to concentrate on essential aspects without drowning in unnecessary minutiae. Example of abstraction in programming. Consider a car class as an example. Essential properties like make, model, and color, along with behaviors like starting the engine, are emphasized. The intricate details of engine mechanics and acceleration are abstracted away, leaving users to interact with the car's fundamental features. Abstraction and real-world modeling. Abstraction is a potent tool for modeling real-world entities, like abstracting an account class in a banking system. Advantages of abstraction. Abstraction brings several advantages to programming. It simplifies complexity, eases maintainability by hiding implementation details, promotes code reuse, and facilitates collaboration among developers. Conclusion. That concludes our journey through these fundamental OOP concepts. We have explored encapsulation, polymorphism, inheritance, and abstraction, laying the foundation for writing robust and maintainable software. Thanks for watching. Please like, share, and subscribe to our channel for next video.